All right, this is the 2018 Series FRQ from the BC Calculus exam. And it's another nice example of one that is pretty representative of what they've been doing the last couple of years. So they give you the function f is equal to x times the ln of 1 plus, well, they give you ln of 1 plus x, and they want you to find this function down here. Notice there are two things. They're substituting an x over 3 in place of x in this series, and then the whole series is being multiplied by x. So always make sure you make a distinction there. Are they subbing in a value, in which case you need to put that in place of the variable, or are they multiplying the function by something or adding or something like that? So anyway, what we've got here is x. So in place of the x, I'm going to put an x over 3. And then we've got an x squared. In place of the x squared, I'm going to put, in place of the x squared, I'm going to do an x over 3 squared. And then that whole thing is over 2. And then in place of the x cubed, I'm going to put an x over 3. And that's supposed to be over 3. And then, sorry, it's a minus next. It's an x to the 4th, but we're replacing that with an input of x cubed. That's being raised to the 4th, and it's over 4, and so on. By the way, I think you guys did this one on your exam, so you thought about this problem already probably, but here's kind of filling in the gaps if you missed some of these things. All right, they ask for the first 4 terms, and they want the general term. Now, you may want to simplify this. For example, you could write this as x over 3 minus, this would be the same thing as x squared over 3 squared times 2 plus x cubed over 3 cubed times 3. I'm leaving it in the same form for a reason here. Minus x to the 4th over, that would be 3 to the 4th times 4, and so on, okay? Now, you could also simplify this, and you could do x over 3 minus x squared over, let's see, this could be 18, I think, plus x cubed over, is that 81? It's like 81, and I think that's x to the 4th over, I think that's 324, kind of doing that off the top of my head. Anyway, for your general term, sometimes you're going to see a really nice pattern in the really simplified one. Sometimes you're going to see a really nice pattern in a slightly less unsimplified form. And I think if you look at this one here, you can see we really have values of x to the n power. And this is assuming that n starts at 1, not 0. And then you've got 3 to the n, and you just have an n value there. I can't see that in this version, but sometimes you get some nice cancellations, and sometimes the simplified one's easier to work with. So, you just have to kind of write things in multiple forms and see what works. Of course, the other version, you could use the original general term. Oh, by the way, there's supposed to be a negative 1 to the... Actually, it's got to be an n plus 1 here if I'm starting at an n value of 1, because we want the first term to be positive. So yeah, I get that alternating series aspect in there too. Now, you could have gone back to the original one, and you could have said it's negative 1 to the n plus 1 times x to the n over n. And you actually could just take theirs and just say, I'm going to put an x over 3 in there and have x over 3 to the n over n. And you could have not even simplified it down, and you could have just left it as negative 1 to the n plus 1 x over 3 to the n over 3n times n. Oh, by the way, I'm not actually done yet. We're actually trying to find x times the ln of 1 plus x over 3. Okay, so far I've just found ln of 1 plus x over 3. So that whole series needs to be multiplied by x, and that's going to give me x squared over 3 minus x cubed over 3 squared times 2 plus x to the 4th over 3 cubed times 3 minus x to the 5th over 3 to the 4th times 4. So actually, looks like our n exponent here is going to be, actually I'm going to use, I think this is the most simplified version. It's going to be x to the n plus 1. So it would be negative 1 to the n plus 1, x to the n plus 1 over 3 to the n times n is probably how I would write that. Okay, I think we're gonna have to use this for something else. So let's check this. And again, you can't do this on the real AP exam, but never hurts to try. Let's see what we got going on here. Yeah, that does look like the same thing I had. Okay, let's go on to part 2. And actually, part B is the last part of this one on the 2020 exam. All right, part B says determine the interval of convergence. Show the work that leads to your answer. All right, so and that's and by the way, it's for f, not for the function that they gave us originally. So we're using this new one here. So I need to use my -1 to the n plus 1 x to the n plus 1 all over 3 to the n times n. And this is a ratio test. Remember, for the ratio test, you're taking the limit of the n plus first term divided by the nth term, and you want that limit, technically, of the absolute value as n approaches infinity to work out to be less than 1. It's kind of a variation on the geometric series test. So anyway, just be careful. Make sure you're substituting your plus 1s in for your n's and not for your x's. X will just kind of stay where it is. So anyway, we're taking the limit as n approaches infinity. The n plus 1 term, that would be -1 to the n plus 2 times x to the n plus 2 all over 3 to the n plus 1 times n plus 1. Okay, I'm going to multiply by the reciprocal of a sub n, and so that'll end up being 3 to the n times n on top, a -1 to the n plus 1 times an x to the n plus 1 on the bottom. We can simplify this. We haven't taken the limit yet, so don't lose your limit notation here. And you're going to have everything except for one of the negative ones cancel. So we have a -1 left on top. We're going to have an x left on top. We're going to end up with a 3 left on the bottom, and we're going to have an n left on top and n plus 1 on the bottom. I'm going to break that up into 2 separate fractions. So I basically got a -x over 3, and I've got an n over n plus 1. We're taking the limit of this as n goes to infinity. So you'll notice there's no n here. The limit of this as n approaches infinity is just going to go to infinity over infinity plus 1, which is basically just 1. And so our final limit here is just going to be, oh, and by the way, the absolute value here is going to knock out that negative sign. So once we've taken the limit, we've got the absolute value of x over 3 needs to be less than 1, okay? Which means that x over 3 needs to be between 1 and -1, and we can multiply everything by 3. It means x is going to be between -3 and 3. So if they just ask you for the radius of convergence, this thing is centered at 0, and you're going up 3 and you're going back 3, and you'd be done. Unfortunately, they want the interval of convergence, so we do need to check and see, does this series converge for 3? Does it converge for -3? And most of the time you can just substitute, especially if they have you write out terms earlier, you can substitute back into the original a lot of times, and you're going to be able to see things. And I think that's going to end up being the case here. So let's see here. If we put in the 3... By the way, we've got all these 3 powers. Sometimes you're going to be able to see this. You're going to have to decide, do you substitute into the general version of the equation here, or do you substitute into some kind of a listing of this series? And sometimes it's tough to tell, okay? So I'm going to test 3 here, okay? And if I just start listing 3's, I would have a 3 squared over 3 minus 3 cubed over 3 squared times 2, plus 3 cubed over 3 squared times, 3 to the 4th times 3 cubed. So I'm going to rewrite that. 3 to the 4th times 3 cubed over 3, and so on. Hopefully you notice some things here. Everything's going to cancel except for 3 here. Everything's going to cancel except for a 3 on top here and a 2 on the bottom. Everything's going to cancel here except for a 3 on top and a 3 on the bottom. And that pattern is going to continue. You're always going to have a 3 on top, and your denominator is going to keep increasing. Hopefully you notice this is really just 3 times the alternating harmonic. Most of these will be either a non-alternating harmonic or an alternating harmonic. And if you notice that, the alternating harmonic is going to converge, okay? 3 times something that converges will also converge. So this will converge for 3. Now, you could have put it into the general formula up here. If you put a 3 in up here, what you'd end up with is you'd have a -1 to the n plus 1. You'd have a 3 to the n plus 1. On the bottom, you'd have a 3 to the n, and then you'd have an n. And what you would see here is everything would cancel except you'd have the -1 still. You'd have a 3 on top and an n. And hopefully you could see that's just 3 times the alternating harmonic. And so sometimes you can see it with the general version of the equation. Sometimes you can actually just list out individual terms and see it. There are different approaches, okay? I'm not going to show it here, but if you substitute -3n, which is the other value you should be testing, you're going to end up with a positive. All of the terms are going to be positive, and the regular harmonic will diverge. So anyway, we've got everything. It will not be allowed to be equal to 3. If you want to see the official answer here, which is also posted on Schoology, we can take a look here. You can see this very messy fraction they have. They get the same range as we do. And then down here at the bottom, you can see that they test 3 and also discuss what happens when x is equal to -3. And you can see a lot of points on this one, 5 points for all of that. So anyway, 2020 exam, they're not going to do the error test, so I'm going to cut off the video right here.